Hello, I'm Karthik from IR College, studying in IR College. My roll number is 230. Today on concept video, my topic is applications of Ohm's law and Kirchhoff's law. So let us discuss about this Ohm's law and Kirchhoff's law and its applications briefly in further slides. So let us go into the slides. First, let us know about the let us know about this Ohm's law and its applications. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Means when a current passes through a conductor between 2 points, it is directly proportional to the voltage across the 2 points. That's the Ohm's law. Here's the formula of Ohm's law: V equal to IR. Here V is voltage and I is current and R is resistance. Voltage equal to current into resistance. This is the formula of Ohm's law, and this is the definition of the Ohm's law. Let us see more in further slides. And here there is the diagram on the Ohm's law. So let us see this. Here A equal to ammeter and V equal to ohm meter and R equal to resistor and B equal to battery, which will be connected, and K equal to key and R equal to rheostat. So the following apparatus, these are the apparatus. So this will be connected according to their places, and this is the Ohm's law diagram. So let us see the applications of Ohm's law briefly. Here the applications of Ohm's law. The main applications of Ohm's law are to determine the voltage, resistance or current of an electric circuit. Ohm's law helps us to find or determine the voltage or resistance or current of an electric circuit. Ohm's law is used to maintain the desired voltage drop across the electronic components. It is also used to maintain the desired voltage drop across the electronic components. Ohm's law is also used in DC ammeter and the other DC shuns to the current. Okay, this we know already, and these are the applications of Ohm's law. And let us know more about Kirchhoff's law and its applications. Here the Kirchhoff's law, Kirchhoff's circuit's law are two equalities that deal with the current and potential difference in the lumped element model of electrical circuits. In Kirchhoff's law, there will be two equalities that deal with the current and potential difference. So here the diagram of Kirchhoff's law, which have some nodes and voltage and a branch and resistors and a loop. So this is the diagram of Kirchhoff's law. Let us know about the types of Kirchhoff's law. Here the Kirchhoff current law, KCL, also known as KCL. Kirchhoff current law goes by several names as Kirchhoff first law and Kirchhoff junction law. The definition of Kirchhoff current law is, according to the junction rule, in a circuit, the total of the currents in a junction is equal to the sum of the currents outside the junction. Here the definition means that current entering into the junction should be equal to the current coming outside from the junction. Here we see the diagram of Kirchhoff law. Here, as I said before, the current entering I1, I2, I3 is equal to the current leaving the junction or outside the junction I4 and I5. The formula of Kirchhoff law is I1 plus I2 plus I3 plus minus I4 minus I5 equal to 0. So let us know more in further slides. And other one is the Kirchhoff voltage law. The Kirchhoff voltage law goes by the several names as Kirchhoff's second law and the Kirchhoff loop rule. And the definition of voltage law, if you go to the definition of the voltage law, according to the loop rule, the sum of the voltage around the closed loop is equal to null. Null means here 0. Uh, the Kirchhoff voltage law says that the sum of the voltage around the closed loop is equal to 0. It should be equal to 0. Here's a diagram to understand about this. Here V VA VBC VAB VBC VCD VDA are four loops, and here's the formula: VAB plus VBC plus VCD plus VDA equal to 0. As we said, the sum of the voltages should be equal to the 0 in a closed loop. So let us discuss some more applications and more about this Kirchhoff law and Kirchhoff current law, Kirchhoff voltage law. Here are the applications of Kirchhoff law. Kirchhoff laws are used to help us understand how current and voltage work within a circuit. As we know, the Kirchhoff current law and with Kirchhoff voltage law deals with this current and voltage. So it helps us to understand about how the current and voltage work within a circuit. They can also be used to analyze complex circuits that cannot be reduced to one equivalent resistance using what you already know about series and parallel resistors. Kirchhoff current law can also be applied to analyze parallel circuits, and the Kirchhoff voltage law can also be applied in analyzing circuits in series. Here Kirchhoff law is applied to analyze parallel circuits in case of current. The voltage law, and here the Kirchhoff voltage law can also be applied in analyzing circuits in series. And this is about the Kirchhoff current law, Kirchhoff voltage law, Kirchhoff laws, and Ohm's laws, and applications of this Kirchhoff laws and applications of this Ohm's law. Thank you.